Babylonian astronomy is one of the oldest known forms of astronomy, dating back to at least the 3rd millennium BCE. The Babylonians made significant contributions to the development of astronomical thought, largely driven by practical needs, such as timekeeping, agricultural cycles, and religious observances. Their sophisticated methods of observation and mathematical calculation laid the foundation for later astronomical advancements in the ancient world. This description traces the origins of Babylonian astronomy, highlighting key developments and their influence on future astronomical traditions. The origins of Babylonian astronomy can be traced back to the early Mesopotamian civilizations that inhabited the region between the Tigris and Euphrates rivers in present-day Iraq. The Sumerians, who established one of the earliest known civilizations in the region around 3000 BCE, were among the first to develop a system of writing and record-keeping, which included early astronomical observations. The Sumerians were primarily concerned with the cycles of the moon and the sun, which played a crucial role in their agricultural and religious activities. However, it was the Babylonians who emerged as the dominant power in Mesopotamia around 1800 BCE, who would go on to refine and expand these early astronomical concepts into a sophisticated system of knowledge. Babylonian astronomy was deeply connected to the lunar cycle. The Babylonians observed that the moon's phases occurred in a predictable pattern, and they used this information to create a lunar calendar. This calendar was based on a cycle of 29.5 days, which closely matched the time it takes for the moon to complete its phases. The lunar calendar was essential for the Babylonians for several reasons. First, it was used to regulate agricultural activities. The phases of the moon were linked to the timing of the floodwaters of the Tigris and Euphrates, which were crucial for irrigation and crop growth. Additionally, the lunar calendar was important for religious observances, which were often scheduled according to the phases of the moon. Babylonian priests and astronomers developed detailed records of lunar observations, noting the exact times of new moons, eclipses, and other celestial events. These records were compiled into large archives, some of which have survived to the present day. The most famous of these archives is the Astronomical Diaries, a series of clay tablets that document celestial events over several centuries. In addition to their observations of the moon, the Babylonians also studied the motion of the planets. The 5 planets visible to the naked eye, Mercury, Venus, Mars, Jupiter, and Saturn, moved across the sky in seemingly erratic paths, which puzzled early astronomers. The Babylonians, however, were able to recognize the periodic nature of planetary motion and began to develop methods to track the positions of the planets over time. The Babylonians used a system known as planetary omens, in which the positions and motions of the planets were associated with specific events on Earth. These omens were used by the Babylonian priests to make predictions about future events, such as the outcomes of battles or the fortunes of the king. While this system was primarily used for divination, it also reflected a growing understanding of the regularity and predictability of planetary motion. One of the most significant achievements in Babylonian astronomy was the development of the ephemerides, a set of tables that predicted the positions of the planets over time. These tables were based on careful observations of the planets' motions and allowed Babylonian astronomers to predict planetary conjunctions and eclipses with remarkable accuracy. This ability to predict celestial events would later influence the development of astronomy in Greece and beyond. The Babylonian contribution to astronomy also includes the division of the sky into a series of constellations, which later became known as the zodiac. The Babylonians were among the first to organize the stars into constellations, grouping them based on their positions in the sky and their apparent relationships to one another. They recognized 12 main constellations, each corresponding to a segment of the sky through which the sun appeared to pass over the course of the year. The concept of the zodiac was not just a way of grouping stars. It was also tied to the Babylonians' understanding of time. Each of the 12 constellations was associated with a specific month in the Babylonian lunar calendar. The movement of the sun through these constellations marked the changing of the seasons and was used to organize the year. This system of dividing the sky into 12 sections became the basis for later astrological traditions, including Greek and Roman astrology. The Babylonians' knowledge of the zodiac also had practical applications. By understanding the movement of the sun and the stars, they were able to create detailed star charts and predict the timing of important celestial events. These charts were used in agriculture, religious rituals, and the planning of important state events. One of the most remarkable aspects of Babylonian astronomy was its use of advanced mathematics. The Babylonians were among the first to develop a positional number system based on the number 60, known as the sexagesimal system. This system is still used today in the measurement of time and in the division of circles. The sexagesimal system allowed Babylonian astronomers to make precise calculations related to the motion of celestial bodies. They used this system to calculate the length of the year, the positions of the planets, and the timing of eclipses. The Babylonians also developed methods for solving mathematical problems related to the movement of the moon, such as predicting the time of the next new moon or calculating the interval between eclipses. In addition to their use of the sexagesimal system, the Babylonians also developed a number of sophisticated techniques for astronomical observation. They built observatories, which were often located in temples, and used simple instruments, such as the gnomon, to track the movement of the sun. They also made use of simple but effective methods of recording their observations, such as marking the positions of stars and planets on clay tablets. The influence of Babylonian astronomy extended far beyond Mesopotamia. The Babylonians' astronomical knowledge was transmitted to other ancient civilizations, including the Greeks, the Persians, and the Egyptians. This transmission took place through a combination of trade, conquest, and cultural exchange, as well as the spread of Babylonian religious and astrological practices. Greek astronomers, in particular, were deeply influenced by Babylonian astronomy. One of the most notable examples is the work of the Greek philosopher and astronomer Hipparchus, who is known to have used Babylonian star charts and observational data in his own work. Hipparchus is often credited with developing the first accurate system of celestial coordinates, which laid the foundation for later astronomical models. The Babylonians' method of using mathematical tables to predict celestial events was also adopted by Greek astronomers. The Greek astronomer Ptolemy, in his famous work Almagest, used Babylonian-inspired methods to create a detailed model of the motions of the planets. Ptolemy's model, which was based on the concept of epicycles, would dominate Western astronomy for over 1,000 years. The rediscovery of Babylonian astronomical texts in the 19th and 20th centuries has provided modern scholars with valuable insights into the history of astronomy. Archaeological excavations in Mesopotamia have uncovered numerous clay tablets containing astronomical data, many of which were previously unknown. These texts have allowed historians to reconstruct Babylonian astronomical knowledge with remarkable precision. Scholars have been able to identify the methods used by Babylonian astronomers to predict eclipses, calculate the lengths of the lunar months, and track the motions of the planets. In some cases, these methods were more accurate than those used by later astronomers, such as the ancient Greeks. The study of Babylonian astronomy has also shed light on the cultural and religious context in which these astronomical practices developed. Babylonian astronomy was closely tied to the religious beliefs of the time, and many of the celestial events that were observed and recorded by Babylonian astronomers were seen as omens or messages from the gods. This connection between astronomy and religion highlights the important role that celestial events played in the lives of the Babylonians. The origins of Babylonian astronomy are deeply rooted in the practical needs of the ancient Mesopotamian civilizations. From their early observations of the moon and the stars, the Babylonians developed a sophisticated system of knowledge that laid the groundwork for later astronomical advances. Their contributions to the understanding of time, planetary motion, and the structure of the heavens were instrumental in shaping the development of astronomy in the ancient world. The Babylonian astronomers' use of mathematics, their careful observations, and their innovative techniques allowed them to create highly accurate predictions of celestial events. Their knowledge of the zodiac, the lunar calendar, and planetary motion influenced later astronomical traditions, including those of the Greeks and Romans. Today, the legacy of Babylonian astronomy lives on through the survival of their astronomical texts, which continue to provide valuable insights into the history of human understanding of the cosmos. The Babylonians' ability to observe, calculate, and predict the movements of the heavens was a remarkable achievement, and their work remains a testament to the ingenuity and intellectual curiosity of the ancient world.